In this lecture, we will explore the process of traversing an array in the C programming language. The content of this lecture covers the following topics. First, introduction to array traversal. Second, graphical representation of array traversal. Third, algorithm for array traversal. Fourth, code for array traversal in the C programming language. And fifth, a simple C program demonstrating the application of array traversal. Let's embark on this enlightening journey as we delve into the lecture, eager to unravel the intricacies of array traversal and broaden our understanding of this fundamental concept. Traversing an array involves systematically accessing each element in a sequential manner, commencing from the index position 0 and proceeding through the array until the last element is reached. This fundamental process allows for the examination, manipulation, or utilization of each individual element within the array. By employing animation, we can gain a comprehensive understanding of how array traversal operates. Visualizing this process dynamically allows us to witness the sequential movement through array elements, providing a clear and engaging insight into the intricacies of traversal. Imagine an array with 6 elements. We access each element in order, starting from the first one at index 0 and ending with the last at index 5. It's like walking through the array, visiting each element one after the other. Let's explore the algorithm used for array traversal. Firstly, we require an array, and subsequently there are 5 steps to follow. In the initial step, we initialize the variable I with 0, representing the first position in the array, holding a value. Here we refer to index 0 as the lower bound. Moving on to step 2, we initiate a loop to access all the elements of the array. In this example, we use a while loop. However, other loop structures can be employed. Regardless of the loop used, the process remains the same. The loop continues until we reach the last index of the array, referred to as the upper bound. The third step involves performing operations on the accessed elements using the array name associated with the index as demonstrated by a in brackets I. In step 4, which falls under the while loop block, we increment the variable to access the next element in the array. Step 3 and step 4 are enclosed within the while loop. They are processed until all the element inside the loop has been visited. Once all element in the array has been accessed, the program terminates. Let's take a look at the animation that helps to grasp the array traversal algorithm. The array in focus has 5 elements, and as we discussed, the initial lower bound is set to 0 and the upper bound is equal to the length of the array. The key components of this program is the while loop, which drives the traversal process. Pay attention to the position of the pointer on the array and the value of the lower bound in the animation. After each pass of the loop, the lower bound changes, shifting the pointer to a new position. Let's harness the power of C programming to implement and experience the practical application of array traversal. The C programming code presented below is an implementation of the algorithm we discussed earlier in this lecture. In this demonstration, we initialized an array of size 5 with specific elements. The array begins at the program start, setting the lower bound to 0, indicating the starting position for accessing array elements. It is important to note that the lower bound can be any value greater than or equal to 0 and less than the size of the array. To determine the upper bound, representing the total number of elements in the array, we divide the total memory occupied by the array by the memory occupied by each individual array elements. A while loop is then employed to traverse through the individual elements. The loop continues until the lower bound is less than the upper bound. Within the loop, two operations are performed, printing the value and incrementing the lower bound to point to the next element for access. Upon accessing all the elements, the program exits the loop and concludes with the termination of the program after printing the last printf statement. Now let's explore a real-world application of arrays to better understand their implementation and familiarize you with data structure programming. We are integrating array traversal into our student attendance project. In our earlier version, we had two lists, one for attendance and other for student name. Now the main aim is to use array traversal to display the attendance status of all students. By going through these lists, we want to show whether each student attended or not, keeping the focus on utilizing array traversal for this purpose. The presented code exemplifies our implementation of the project we discussed earlier. It incorporates the previously provided code for array traversal. A new feature has been introduced to check the attendance status of student on a given day using an if-else statement. I encourage you to try this code on your machine for a hand-on experience and a deeper understanding of the concept.